Hello, everybody. Welcome to the meeting. My name is Vaibhav. I'm the team lead. This is Cyrus, second in lead. This is Paul, our special technologist, and we have H2, our media expert per se, and also our special technician. Unfortunately, Dilpreet wasn't able to make it due to family emergencies, so she won't be with us. So for now, just us. Let's dive into this. Yeah. We all decided to do a project, take on a project named the Dory. We still haven't figured out a name for it, but we'll get to that soon, right? So
Dory is a pretty good name so far.
Dory is a pretty good name, not gonna lie, yeah. Let's dive right into it. Freehand drawings. We started having some freehand drawings. Um, we did have some challenges. We mainly it was H2, Hashim, who did the freehand drawings that we got. So, take over.
For the freehand drawing, it was mostly not that hard to do. The only struggle that was like we had to bring it down from like I had to scale it down from inches to centimeters, and that was my scale. It was hard to make the curves and make sure that it is 1 to 1 compared to the 3D model. Um, Otherwise, everything else was good. We were able to put on a good template, make sure that we have all the angles, which is the front, top, and right angle. But otherwise, everything else is good.
So, what was your main way of thinking? What was the main idea behind the concept that you made?
The main idea was so when we get to the 3D, like the 3D modeling in SolidWorks, it would be easy for us to make sure that like all the sizes are right. We were able to make it into 3D, um, and we also have like would also have like the right angles in certain spots that we have, which is like where the claw mechanism of its opening and closing. We make sure that it's all 45-degree angle or 150 from the outside, depending on where we're looking at it. Um, Other angles that were important, which was the claw initially had a um, three sections, which are 30 degrees each, and that helped make it more versatile when picking up certain objects. We had to make sure that we include that in our drawing too.
Nice, nice.
I just wanted to like give feedback because I saw the sketches.
Yeah.
Like next time you had face, all the faces should be lined up with each other because for the claw one, the
The
front
the
the front wasn't lined up with the right
Um,
side view, so they should
Yeah,
always be
yeah.
lined up.
The
Yes,
the front and the top were, but on the right side it was I wasn't.
but other than that, everything was pretty good.
Yes. Thank you.
Great. Oh, thank you. All right. So, was there any changes that you made in the process of finalizing your drawings? What was your original compared to what your final? What was the major changes that you made?
In the beginning, what's it called? I was this what's it called? I was thinking like which side we should do because uh, the front and back are different. So if you only give that sketch to a person who is 3D modeling, they wouldn't be able to know what the other side of it is because the what's it called? Like the mechanism of opening and closing on the front side had two big circles and two small circles, but then the back side had four small circles, so they wouldn't know what's different. So I had to choose one of them and then put an on the side that in the back side is a little bit different.
So maybe next time like have an extra view maybe.
Extra view, yeah, or have like an isometric, like full
Oh,
isometric,
okay.
yeah.
I'll keep that in mind.
Really nice. All right, thank you, H2. All right, so obviously from two freehand sketches, we move on to 3D. And mainly 3D modeling was done by our dearest Cyrus. So Cyrus, how was 3D modeling?
Yeah, well, you started it off, so that gave me like basically the
Yeah,
general shape of everything, and
yeah.
then from there I had a list. It's a bit of a long list of like all the parameters when we made the freehand sketch, right? we submitted, we had like the general parameters that we had to hit. So the minimum height, maximum height, the maximum weight it should be, the type of motors we're going to use and everything. So I tried to incorporate all of that into the 3D modeling.
Mhm.
And so far, like the progress has been pretty good, and we're almost there. The only thing we need to work on would be making the final assemblies. And since we did decide to change certain fastener types, we had to adjust the hole sizes on our 3D model. Well, other than that, the 3D model itself is complete. So I can go over some changes that we did make. So one would be initially we had the design of using tracks for for the wheels itself, but when talking over to Professor Ali, he mentioned that maybe, as I mentioned, the locomotive mechanism, and he said he preferred that one. So I have to adjust the 3D model based off of that. And then another change that we made was the placement of the clock, because you gave feedback that when the scissor lift is fully extended, it would
Mhm.
be off balance, right?
Yeah.
So what were the suggestions that you made again, based off of like how to set the balance?
So basically, what did suggest is since the claw would be sitting at the very edge of
Mhm.
the base of the scissor lift, I would suggest that you move it to the center or close to the center so that it evens out. So whenever you're picking up a load of, let's say, 1 pound or 2 pounds,
Mhm.
it won't tip over since the material we'll be using is acrylic 3D
Right, right.
printing and it's not going to be too heavy. So shifting over the claw machine, the claw mechanism to the middle would stabilize
Mm.
the entire scissor lift, including the base. But I also do suggest that you add weights into the base, since the base does have a hollow where your components, your electronics, your motors, and everything's gonna go. I do suggest you use some sort of weights that would be going into the opposite end of where the claw would be facing. So let's say the clippers would be facing the right side. On the left side, the opposite end, you
Oh,
would put in, let's say, weights
right.
or substitutes of weights, like a fishing lead or something like that. You put it in so that when you do tests and you do pick up, it won't tip over. It'll be balanced out.
Yeah, the center of gravity would
Center, yeah.
What
be lower
about
in the
like
middle.
the phone when it becomes like closer to the end? Are we gonna keep it all to the left side and the claw on the right side? Because then it will
So
get so weak that it will fall, right? So we have to make sure that like how you said, center of gravity should
right.
be in the middle.
So that's why he was mentioning how if you added weights at the bottom and moved so let's say this is the scissor, the claw, and this is the scissor lift. Closer it is to the middle, the center of gravity would also be close to the middle, so you'd be less prone to tipping, right? And if we need it, we can also add extra weights at the bottom just to bring everything.
But only on the bottom because doesn't need them doing top because they're both moving.
So it'd be counterbalanced, right? Like if force would be on this end, counter it on this side,
Yeah.
right?
Right.
Yeah.
So I guess that would be one of the challenges that we did
Yeah.
face was balancing out the entire mechanism of this product of the product. Some other
And there's also another thing where we have to figure out what angle we have to make so that we don't fully collapse it
Right.
because it will be hard to bring it back up
Right.
and not fully extend it so it doesn't get weak enough for it to fall even with the weights.
Right. So you mentioned in the freehand sketch, you mentioned that initially we said 45 to 150. So after making the 3D modeling, our actual range, the minimum angle would be 30 degrees and the maximum would be 160.
Yeah.
So I had to adjust it based off the motor that we chose for the lead screw.
Yeah.
Based off of that stroke, that was the what we could get
Yeah,
looking at the
that's true.
3D model.
um overall, I think we are in the process, especially specific to 3D modeling, uh practically almost done.
Mhm.
And we're in the process of reviewing the changes that we have made, reviewing everything in terms of if what if situations. If we test it in terms of we run it through rocks, we run it through sand, we run it through water, or run it through windy conditions, how will it affect the mechanism, the balance, and the the structure of this project, right? How would it affect it? Where could it go wrong? Where could it fail? What could change in different temperatures and whatnot? So right now we're in the process of testing and seeing what could potentially go wrong, and we're gonna edit and we're gonna change those certain things as we move forward. Should be done within the next week. So
Uh, if I was like, what's it called? I feel like the what's it called to make it more balanced and more like durable in different like situations. I feel like the weight should be more centered on the bottom compared to the top, then it can be like more grounded in a way, but not too grounded. So then the motor will be able to move and like move the steer lift, right?
Yeah, so we're using geared motors, and it shouldn't be a problem in that situation. But based off what you're saying, if you have a force on one side, you would want to counteract to the other. If you're closer to the middle, you're gonna be adding onto that force, and cause
it'll tip
it'll
over
tip over still, but it's better farther away from
farther
the
away.
center.
Yeah.
Yeah. So 3D modeling is, I guess we can say, on a successful track and it's on track. But along with uh, the 3D modeling, we also know that we have to keep track of our BOM and the components that we'll be needing. So that portion is I have dedicated to Paul, or specifically to electrical components. I've dedicated that to Paul since he is an expert in electrical components. So Paul, over.
Thank you. Currently, we're waiting on the components to arrive. So I've only been able to simulate to make sure that all components work, all the components would have something to test if they work or not.
Interesting.
Okay. Due to some components being missing, I replaced them with something that could be replaceable. Like we wanted a limit switch to indicate this is how far it could go. The machine could go up or the bottom, and we don't want it to go over or else it will cause problems. So I replaced those with button switches, and once the components come in, I'm going to test out each component to see if the code currently will work with that. Looking at, we are going to need two motor controllers. One motor controller can control two motors, and we have a total of three motors and one servo motor. The two motors are going to control the wheels, and the final is a motor connected to a jack screw. That since it allows it to move up. Currently, we don't. I'm not too sure about how many revolutions it's going to take, so we're just going to hope that the connection is fast enough to prevent any friction issues later on. As for the servo, it's going to turn like 90 degrees, yes, to for the claw to open and close. Right now, at first I was going to go pure circuit, no resistor, because I thought it would be fine. Later on, I found out that the limit switches need resistors when grounding, or else they'll be cooked. So I had to add that to what we had to buy. And power source, I'm stimulating everything with a 9-volt battery. Well, once we're actually going to make it, I'm thinking 12 volts because of how much things we have to power.
Did you try including capacitors or no?
Capacitors are not necessary in this case.
Okay.
It's only the resistor
That were necessary there. Yeah.
I have a question. So, like, where would we get like a 12-volt source? Like, what would it could be used for that?
that get we could get a few batteries, connect them in series, and that adds up to 12 volts. Or
It
or
should be parallel.
No,
Parallel,
because then the
series.
voltage would be the same.
series parallel volts.
Both stay the same in
True, yeah,
series.
true. But like, so then we should get like four 3 volts batteries, and we can do that.
Yes. Another option is just start with a 12-volt battery.
Right.
Like there are some batteries you can find online.
Those big ones, right?
Yeah.
but
Then
we're uh, including that in our base, but we're in that like to throw off some stuff.
No,
that's
no, it's
actually
included in it. That we kept that into account. No, anything aside.
yeah. That's also
So
at the weight.
But then you guys keep
Oh.
account. You guys keep account a 9 volt battery. A 12 volt battery usually is heavier,
Nine was small.
but it's small amount.
It's
It doesn't
they're
usually that
small.
much.
We
Yeah.
should keep note of that where because we to offset that weight, since the battery does have as a good point, that we should put it where we want to add the weight
mm,
at the end.
Oh yeah.
The mounting point.
so
Even the breadboard and stuff, we could just try to mount it as far as possible
yeah,
from the clamp.
yeah. But
The breadboard it doesn't have much weight at all. It's the battery that's going to be something we need to keep into account.
We're dealing with grams here, right? So
Yeah, yeah, sure.
so have you taken account into how much of a difference you're talking in our budgeting? Because if you go from 9 volt to 12 volt, it's gonna be price
The-
difference.
Yeah. Well, the difference, I think maybe
I could take a
most 9 volts are pretty cheap, whereas the 12 volts go 20 above. 9 volts are like good under 10.
Mhm.
So it's gonna be quite a big difference.
Mm.
Would we be allowed to? I like we already have existing power banks. I wonder if
Yeah.
we can ask them. If we just use because we can direct plug. You know how we have a power bank,
Mm.
like you just plug that directly and use it for that purpose.
Yeah.
At that
But then
time.
that would cause problems into our base because not all power banks are small.
Right. Like what existed when we have
The one that we have right now
Yeah.
are the size of a phone.
Yeah.
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 So
Yeah.
that would fit.
Yeah.
Um, so
Yes.
this is a good example. We
Yeah.
have two 3 volt batteries are $18. So if we have four of them, that will be 36 plus tax, so around $40.
Mm,
Yeah,
no,
okay.
that's over.
Another
But
That's
again,
over budget.
yeah,
another thing we do is grab 9 volt, two 9 volts since they're both pretty cheap,
Mm.
and then have a resistor make
Oh,
stepping it
yeah.
down to 12 volts.
That would work.
does you want a bigger battery?
No, just two 9 volts. That makes it 18. But if we have enough resistor, that will drop the voltage.
So maybe like a 1000 K. Sorry,
No, you'd have to do
1K.
the math on that,
Yeah, we have
depending on
to.
how much current you're pulling, right?
Yeah.
Because at that, when you do it like that, it depends on which motors you're using.
Yeah.
So at that moment, the voltage was, but like you would have to calculate it based off when all three motors are functioning and two motors. So, but we could do it that way too.
So a problem that would occur into that was calculating for amperage.
Right.
That's
Yeah.
what's the biggest problem.
Because it fluctuates based off what you're doing at that time. So
Yeah.
it might be difficult.
Okay. So I feel like this is something that we all need to take a look into because we we will get into our budget soon, which would be your point, Cyrus. But um, I do believe that we need to have some range of saving. We cannot go too close, too tight to our budget since it is only $200 budget. Um, so I think we should keep working on it, take a look into alternatives on how we can change um, the battery. It is a good idea where battery we can use as a weight instead of going out and buying something else and putting it into the specific position. We can just position the battery in terms of where we want to balance the entire thing out. So that is a good idea, which would which should be considered. But overall, I think the electrical is looking good. We still need some work on the batteries and finding a proper solution to how things will be running later on. Yeah. All right, moving on to our bill of materials.
Right. So me and you worked on this
Yes, sir.
the other night, and just to update everybody, so we have two different price totals. One price totals based off of if we didn't include the electrical component, just because of how the classes are structured. Apparently, it's a different budget for the programming and for the design class. So like the Arduino components and everything, we're not sure yet whether we would bill it to the design class or bill the programming. So excluding like all the electrical components. So we got the Bluetooth receiver, the motor drivers, and the breadboards. Our price before tax would be $140. That's our total
Yeah.
for everything. But then if you include like the electric components, Arduinos, it would be 150, 142 before tax. So it's a pretty big difference, right?
150
One
So you're
point
saying a $10
42.
difference?
without tax, right?
Yeah, without tax.
So only $10 difference?
The dollar difference would be roughly like 40,
Mhm.
40 to $50.
Yeah.
So 151.
Oh, 104. I thought it was 140.
Mm.
Okay, yeah, yeah. So it's not that much.
So that's a $47 difference
Yeah, yeah.
before taxes,
That's
right?
true.
So um did you know like now we have a $200 budget
Mhm.
budget? Is that before tax or after tax?
That's including tax.
Including tax?
Including
So yeah, so that means we're cutting it close because after tax with all the electric stuff, it's $171.
Yeah.
Yeah, so and that's something like we really can't avoid. Like everybody tried it yesterday. We already tried to find like the cheapest possible fasteners available.
We
So
also don't want it to be very weak, right?
yeah,
Yes,
well,
okay.
in our application, as long as it's metal,
Yeah,
it should
that's
be
it,
fine.
yeah.
And then we also simplified it where before we had three different types of fasteners or four, so we narrowed it down to just two fasteners. So it'd be a number six and number eight. So small diameter, big diameter, and made them all the same length. So even though there's areas where you don't necessarily need that long of a fastener, we'll just put a long one in and just have an overhang. Just because instead of buying two different sizes, that'll double your price, right? We just bought one pack of 100 for $12, right? Instead of so you have the cost right there. Instead of buying another size, there's another $12, so it'll be double the cost. So we did that for both. And then yeah, we chose the different motors for the BOM.
The servo motor, we couldn't find anything that is cheaper.
Right. So that's another one that we were talking about where um just because of how the application that we're using the servo for, we want it to be a bit strong. Right?
Mhm.
So if you choose like we could buy a $10 servo or something, but it might not be strong enough to pick up what we want. Like we want it to be able to pick up like 2 pounds.
Yeah,
Right?
yeah,
So
that's true.
there's that. Well, yeah.
So again, as I mentioned, we are tight on our budget
Mm.
because it's only $200 including tax, right? And if we do the difference from 171, including if worst case scenario, if we have to buy electrical components plus all the components that we need, it's around $172. If you do the difference, that leaves us less than $28 to spend,
Yeah.
right?
What else do we need to spend for that?
Huh?
What do we need to spend for?
Like I remember like from last semester, we don't know yet, but we want to be
Conservative,
just
yeah,
for
yeah.
just in case scenario.
Just in case. So
Well,
for
we might need
example,
something later
Does that
on.
include the battery though?
No, see,
Oh, yeah, there you go. Okay.
exactly. If you're telling me you're gonna spend $36 on batteries, you're over budget already,
Yeah,
right?
for
So
sure.
we need to make sure that it's we'll continue working on our bill of materials, seeing if we can find anything cheaper, stronger, but on a lesser price. If you find it, by all means, we will prefer that. If we cannot, then unfortunately we will have to find alternatives and based off batteries, we gotta find a way to fix it or alter our structures of how much power input we need to put in each wheel or each motor. Um, but that's something that we need to work on, right? Budget is tight. It's hopefully, fingers crossed, it's not gonna be tight. And our other professor does give us the
right.
Arduinos and Bluetooth modules, everything that we need for electrical components. So fingers crossed, we'll be at $150 cap, and then we'll have $50 to margin in whatever fun stuff or whatever extras you want to do to enhance project. Yeah.
Yeah, I just wanted to add on like I guess to go over with Ali if we're allowed because he said I own the 3D printer, right? So it's
Mm.
like you can use your own 3D printer if you wish.
Mm-hmm.
So I wonder if you can say the same thing for just to make the BOM better. Like we already have resources, personal resources.
Yeah.
I'm willing to share to
Yeah.
the group. Like
Yeah.
a battery pack, I think I could provide.
Yeah. So
I
Yeah.
could also provide
Right.
some. I
So
have
if we're allowed
my
to,
yeah.
then we can. I'm willing to give some of my stuff
yeah.
also.
So
Yeah,
Yeah, some lithium ions. Because
you got a lot.
yeah. So wherever we can, we will purchase. If we cannot, we will have to resort to alternatives or changes into the project. Or if members are willing, then we can use their resources and we can return it after. Yeah. All right. Coming to an end. Um, Unfortunately, Dilpreet wasn't able to make it due to some family emergencies. So she is not here, but I will be taking over her role. Um, our to-do list. Okay. For the next week and a half, 2 weeks. That is our to-do list. And well, mainly a week. I say 2 weeks just to give you some room to breathe. Electrical components.
to do it, I have to do all test out all like all the electrical components are working,
Yep.
and then actually build the circuits, you know, to make sure everything works compatibly.
Yes. Make sure that they are working and there's no loose ends, there's no problems, there's no malfunctions, and making sure that batteries are not dead. Right?
Yeah, you got
It better not be dead. The presentation day we're gonna have a malfunction, it's not gonna be good.
all that testing, and then there's
Do you have a multimeter? Yeah. Okay, perfect. Okay.
Alright, so electrical components, that should be good enough time. Like, a week's time should be good. From now till next week should be good amount of time for us to find resources, fix the problems and issues that we are having, and finalize at least a prototype of what we're thinking of doing,
Mhm.
and start building that prototype.
If you need
Yeah.
any help with like building the circuit, I can help you and the code too.
Got it down
You're
already.
gonna do it already? Okay. For you to troubleshoot anything.
Troubleshooting, yeah. If we get there first.
Next thing on the to-do list is their 2D drawings, which I'll be taking over. You sent me, uh, need to send me the finalized
Right.
assembly so that I have the final assembly because that's the only thing that I need from you. I'll be finishing that within this week, so you guys will be having that to review over, see if I have made any mistakes. Unfortunately, I'm also human, not a robot. We all make mistakes, so I'll be sending that over for you guys to review, take over a look. Well, okay. And lastly, we need to send out so electrical components and 2D drawings are the big two ones that we need to finish within this following week from now till next week. Those are two big things that we need to get out of the way and finish it off and finalize. The last thing we need and last thing to do is to send the parts to laser cut or 3D modeling. Because laser cutting and 3D modeling is going to take a while because it's not one component we're printing or laser cutting. There are about 140, 150 components.
Oh yeah, I wanted to mention, can we send out just a test laser cut file, some of the stuff just to make sure our fitment is correct? Like I don't want to send
Yeah,
so like
yeah.
just I just wanted to send out like a test piece of like different hole diameters and then another one the pins that go in to see how it will fit. And so I would know like what the tolerance is if it's like an extra 1 millimeter or half a millimeter. So then I
Yeah.
can adjust our drawings
Yeah,
based off of that.
so I can talk with Ali for that. I'll let him know that we want to do a testing, and
Yeah.
if he approves, then we can send out a laser cut to Scott downstairs, and we should be getting it. Hopefully, he's not busy because it is
He's very busy.
he is busy. Oh, great!
There's a 6 day wait.
Yeah,
Exactly.
actually, I mentioned it to him already with Ali, but he
Mhm.
told me don't even talk to him about it, just send it over. So like we don't even have to go through them. We can send it over to Scott, but I'm guessing we have to talk to Scott about it. Or Like, will they just do it automatically? Like, if email them,
I can talk with
like,
Ali and I can figure that out for you guys.
like, do they just email it directly? Like,
Email there.
and then
There
like,
should be an email at the bottom of
yeah,
the thing.
I have that email, but
You
like, do I have
can.
to talk to someone or like once I send that email, they'll automatically print it?
I am actually printing something right now. It's on the way. We could use that as a gauge to see how
Sure.
accurate it is compared to my drawing.
Okay.
Yeah, you can do that.
It should be coming in about next Tuesday to Friday.
Okay,
Yeah,
so
that's a long break.
so we know since he has said something that it is a long wait and we are tight on schedule because this whole project will be due in 4 weeks. Less than 4 weeks actually.
Yeah, presentation the 21st.
21st. So we have less
22nd.
What can we second?
we have
No,
less than
but that's a month. That's 5 weeks.
well we don't count the last week, so less than
4 weeks.
4 months. Or sorry, 4 weeks. Right? And it's gonna take about a week and a half to print. So we are tight on schedule. We need to finalize the first two things and send out everything to laser cut and 3D printing within this 2 week period. Okay, so there's the laser cut and 3D modeling that should be going out around next week. Today's the what? 14th, so 21st.
If it's a 6 day, right? Because our actual pieces that we need to be laser cut, they're already complete. We don't need to revise them. So we can actually make the 2Ds for that.
Yeah.
Paul showed me, were you gonna make because Paul showed me how to do like a specific export for laser cut as like separate from the 2D
So
drawing.
if you showed you, then it's probably easier way. My way is a bit long, so
Okay.
you can use his way.
I had to go ask God.
Yeah, Scott taught him.
Okay.
We had a mistake.
Yeah, no worries. So you can use his way. If
But that's after I find the tolerances. So just in case I don't want to print all of them.
exactly, so we do want to save time, not just for us, but also for Scott because he has a lot of projects on his hand as well. Right? We don't want to waste anyone's time. So we want to make sure that everything is finalized before we send anything out.
Right.
So please make sure within a week that the electrical components are finalized. 2D drawings, I'll be finishing it off and I'll be sending it to you guys for a look over and to confirm if there's any other mistakes. And I'll also confirm it with Ali Taha if there are any other mistakes. By 21st, everything should be done. And on the 22nd, we should be sending out anything that we need to send for laser cutting or 3D printing.
21st, is that next week?
Next week,
Okay.
yes. So 22nd or 25th, the following the next Monday.
Right, because it's busy.
It's weekends, so they're not gonna do anything. So on Monday, so let's keep it Monday 25th, March 25th.
Actually, just because if there's people sending it on the 21st, we would still, so it would be good still. It's just going to be done on the.
Exactly. So I am a little flexible with what day you guys want to do it. If you guys choose the 22nd, everything needs to be done and submitted by 21st. Or we can have it on the 25th. So I give you two options. Which one you guys want to do? 21st or 25th?
You want to aim for 21st, and then if it doesn't work, we go.
Pick a date. No.
We'll do 21st.
We'll do
21st?
21st for now, yeah.
21st it is then. So everything should be submitted in for the 21st. Okay, so electrical components and 2D modeling, and I'll be sending that to you halfway through the week. So 21st it is. 22nd we'll be sending it out to 3D printing and laser cut. And that's basically it for the next 2 weeks. So just to go over who has what, okay? Paul, you have electrical components to review, optimize, and enhance. I have 2D modeling to handle and complete. Make sure everything is up to standards, up to date, and everything. Cyrus, you have to finish your finalized 3D modeling and send it over to me. And you need to figure out the tolerances on how the laser cutting is going to happen. Obviously, you can work with Paul since he laser cutted everything. H2, you are going to also, again, as I said, you're going to assist him, Paul, in terms of if he needs help with how the battery's gonna work, or if he needs any extra hand, you can help him out. But your main focus right now should be
The
on
banner and the pamphlet.
yes. So focus on the banner, on how figuring out how big, how wide the banner is gonna be. Um, if it's gonna be on a roller, if it's not gonna be on a roller, it's just gonna be one big sheet with a stand behind it. I want to know how it's gonna be looking.
He said it's one big sheet, 24 by 36. But do you guys want it to be landscape or portrait? So
Portrait was that you showed me. It was portrait, right? Like
It's straight
the
up, yeah,
chair from
portrait,
so
yeah.
then we'll go with portrait. Make it then make it then uh, 24 by 36.
Okay. And brochures, obviously you have shown us a few brochures, and we have yet to decide which one we'll be going with. But keep working on all of them on simultaneously, seeing which one looks better in which terms. And by end of 21st, you can again when we have a meeting again, you can show it to us, and we can finalize the brochures as well. Along with obviously, if you're done with the banner by 21st, you can show that to us as well.
How about will be done by both? Yeah, should be fine.
Yeah. So banner slash brochure.
Because brochure is almost done, banner is from scratch.
One more thing you have to keep in mind. There's also a video,
Yes.
right? For the
We
commercial.
yes,
one
we
we
do have a video. So
Yeah.
that video will be done after everything is completely and it's built and it's operating.
Right.
We will have to do testing first before we do any videos.
So we would want that's why we want to finish it as soon as possible.
Exactly.
We still have work afterwards, right?
Yeah.
Like,
I feel like we should make two like practice videos, and the third one would be like the finalized version, and we'll edit it and make sure everything's good.
whatever you feel.
Yeah, because at the end of the day, we wanted to make it like as ready as possible for people that look at it. Right, it's not going to be all the teachers; it's going to be a lot of people coming in and looking at it. So yeah.
So we'll leave the video making and testing for the last 2.5, 3 weeks. So we have time to play around with it. Um, but that is for after everything is built. So that's very down the line, but it's good that we have an idea of what we want to do. But please do mainly focus on electrical components, what we need to finish before the 21st. Because those are, if that's not done, we cannot move forward,
Yeah, so
right? Because we need to submit everything on the next week,
Yeah.
right?
to add on to that, thanks. We need to find out the lead time because we just submitted a BOM. I'm not sure. Like, I'll need some of those components to test them out, right? So
Yeah. So Ali Taha did mention that he already sent out the BOM
mhm.
to the technician, and he said that the motors and some of the things may take 4 to 5 days to come in.
Okay.
Again, so the orders, even the ordering part, it's gonna take time. It's gonna be time consuming, and it's like as soon as the parts come in, we gotta get straight to work, right? So it's better to have all the parts ready, cut out, and printed, so that when the components do come, we're ready to just assemble it in, screw it in, and we're done with it, right? So all the parts have been ordered, they've been sent to the technician. Depending on, since there are many groups, there are many sections, the technician may go and order how Ali has sent the emails.
Right.
So if our email has not been sent first, then we're gonna be delayed by whatever time, right? Or if he's ordered it all in one shot, hopefully we'll be getting everything with everyone else's, right? So I will.
So I've already seen a lot of people get their stuff. I feel like
That's their own that's their own thing,
purchase.
their own purchases. They didn't go through our budget.
Just given that time frame, 2 to 5 days, that means if we want the electrical done by next week, if it runs back, we'd have one day to test it out, right? So
Yeah,
we would want that means you would need another week.
exactly.
Instead of,
Right. So
oh, and another thing, like a good thing to like one good thing about this is like you can test the electrical components without all the laser cut things, like how like you can wire it just like how you did in a simulation,
yeah,
so you don't need them
yeah,
simultaneously.
Yeah.
exactly. So try finding online simulators for electrical components
We do. We have Fritz.
or even motors or whatever components you need to test. If you don't have a physical one and you need to test it, try finding a similar component online to simulate how it will be how it will run, and see if you have a visual representation or a good idea of how to assemble certain things or how you have to do or place things into the project.
Yeah.
Yeah.
But I meant like physically you can build the motors without the scissor lift.
Yeah.
Oh yeah.
Uh,
Oh yeah. Yeah.
I don't know why I'm thinking about this again, but what was it called? Remember how we were talking about the battery situation?
Okay.
So, like, what's it called? Is that gonna wouldn't that alter the 3D base?
No, so when we got decided the dimensions in the beginning, we accounted for that, so we actually have a lot of like extra
Leeway.
space
Okay, okay.
in there, so it's not tight at all. It's
Okay,
like,
okay, that's it.
we're gonna-
Just in case we
yeah.
need to buy 4 3-volt batteries instead.
There is good space for it, so
Okay, good.
good in that format.
All right.
I have 3-volt batteries quite a lot of times.
Yeah, I have that too. I either have the 9-volt batteries or the 3-volt batteries, but I don't.
I guess we'll build a school first, right, and then
Hey, we'll see.
before we use our wallets.
We'll see.
All right. Is there any other questions, concerns, anything to address that I have missed out? No.
Electrical components for a banner and a brochure plus electrical components. Him is 3D modeling. For you, it's the 3D.
Remodeling and approving and uh approving everything. Yes.
Making sure that's all done by the 21st.
Yeah.
Maximum 25th, but aim for the 21st.
Yeah.
And we should be good, yeah.
All right. So with that, in spirit with Dilpri, I think we can conclude this meeting. Thank you for coming. First, from such a short notice. I hope you guys will work hard and finish this project on time. I will see you guys in the next meeting.
See you.
See you. All right. Let's get this thing started. We all